Good morning, everyone, and welcome to today's session. I am Kadali Swathai, and I am excited to guide you through our topic today. We are part of Mala Reddy College of Teacher Education, pursuing our MED in Semester I for the years 2025 to 2027. Today, we will explore the fascinating world of understanding linear equations, specifically tailored for Grade 9 math. In this presentation, we'll cover the basics of linear equations, their importance, and how to solve them effectively. So let's get started and dive into this engaging topic together. When we look at a linear equation visually, it forms a straight line on a coordinate plane. This simple yet powerful visual helps us understand how the equation behaves and where we might apply it in real-world situations. The general form of a linear equation is x plus b equals 0, where a and b are constants. It's important to note that a cannot be 0 because if it were, the equation would lose its x term entirely, and it wouldn't be linear anymore. A key characteristic of a linear equation is that the highest power of the variable x is 1. This means you won't see any squared terms or roots of x in the equation. Recognizing this helps us distinguish linear equations from other types of algebraic expressions. So, what exactly is a linear equation? It's a fundamental concept in algebra because of its simplicity and versatility. It describes a straight line, and understanding its form and properties allows us to solve many practical problems efficiently. These foundational properties are like our toolkit for solving equations. They help us strategically isolate the unknown variable, which ultimately leads us to the solution. For example, if we know that a equals b, then multiplying both sides by a number c, where c isn't 0, gives us ac equals bc. This is called the multiplication property. It's important to remember that as long as we multiply or divide both sides of an equation by the same non-zero number, the equality stays true. That's the core idea behind the multiplication and division property. Similarly, the addition and subtraction properties tell us that if we add or subtract the same number to both sides, the equation remains balanced. For instance, if a equals b, then adding c to both sides results in a plus c equals b plus c. Understanding these properties of linear equations is crucial because they allow us to manipulate and solve equations effectively. They help us isolate the variable while keeping the equation balanced, which is key to finding the solution. So, mastering these properties gives us the confidence to approach linear equations systematically and successfully. Let's take a closer look at the three main types of linear equations based on their solution sets. First, we have identities. These are equations that are true for all possible values of the variable. For example, an equation like 0 equals 0 is always true, no matter what number you substitute in, meaning any real number is a solution. Next, we have conditional equations. These are true only for specific values of the variable. For instance, an equation like x equals 3 is only true when x equals 3, so the solution set contains just that one number. Lastly, we have contradictions. These equations are never true, regardless of what value you plug in. An example would be 0 equals 4, which is impossible, so the solution set is empty. Understanding these types helps us better interpret the nature of the solutions we encounter in linear equations. Let's look at this line passing through the points 0, 1, and 2, 5. This is the graph of the equation y equals 2x plus 1. Now, when x equals 2, we can substitute into the equation. Y equals 2 times 2 plus 1, which simplifies to 5. So we plot the point 2, 5. Similarly, when is 0, y equals 2 times 0 plus 1, giving us 1, so we plot 0, 1. Next, to graph y equals 2x plus 1, we need at least 2 points. Once we have those points, we draw a straight line through them. This line isn't just a random line. It represents all possible solutions to the equation. Every point on this line satisfies y equals 2x plus 1. To find more points, we can choose different x values, plug them into the equation, and find the corresponding y values. Plot those points as well. When we visualize linear equations on a coordinate plane like this, it really brings them to life, showing their characteristic straight line form. It's a powerful way to understand how the equation behaves across different x values. Let's take a closer look at how linear equations can be expressed in different forms, each highlighting specific aspects of the line they represent. These forms are really useful for solving problems efficiently. First, we have the standard form, which looks like x plus y equals c here. A, b, and c are constants, and this form is particularly helpful for quickly finding the x and y intercepts of the line. Next is the point-slope form, written as y1 equals m, x1. In this form, x1, y1 represents a specific point on the line, and m is the slope, or the steepness of the line. This form is great when you know a point on the line and its slope, making it easy to write the equation from that information. Then there's the slope-intercept form, which is y equals mx plus b here. B is the y-intercept, the point where the line crosses the y-axis, and m is again the slope. This form is very handy for graphing because you can directly see the slope and the y-intercept. Overall, understanding these different forms helps us analyze lines more effectively and choose the best approach depending on the problem we're solving. Let's look at how linear equations help us solve real-world problems, like budgeting. Suppose you have a budget of $170 for school supplies. Each item you want to buy costs $50, and there's a flat $20 shipping fee. Our goal is to figure out how many items you can afford within this budget. The equation representing this situation is 50x plus 20 equals 170. Here, x stands for the number of items you can buy. To solve for x, we divide both sides by 50, which simplifies to equals 3. Then, by subtracting the $20 shipping fee from the total, we see clearly that you can buy 3 items. This process shows how linear equations give us clear, actionable solutions to practical questions. In this case, it helps us determine exactly how many items fit within a specific budget, making math directly useful in everyday life. Now, consistent practice really helps strengthen your analytical thinking and problem-solving abilities. When you work through linear equations regularly, you start to build confidence in mathematics. This confidence is essential because it encourages you to tackle more complex problems without hesitation. Mastering linear equations is not just about passing a class. It's a key skill for success in many advanced areas like higher-level math, physics, engineering, and economics. These fields heavily rely on understanding and manipulating linear relationships. Linear equations are also incredibly practical. From budgeting your expenses to creating scientific models, they help us analyze relationships, make predictions, and find solutions in real-world scenarios. They're everywhere around us. Additionally, linear equations serve as the foundation for more advanced algebraic concepts and coordinate geometry. They provide a solid base for your future math studies, making everything that comes next easier to grasp. And overall, linear equations are more than just a math topic. They are fundamental elements that unlock deeper understanding and practical problem-solving skills. This is why mastering them is so important in your mathematical journey. Are there any questions? Feel free to ask about anything we've discussed so far. This is your chance to clarify any points or dive a little deeper into specific topics. Remember, understanding these concepts thoroughly is key to applying them effectively. So, don't hesitate. I'm here to help clarify and ensure everything is clear. Let's make sure we're all on the same page before we wrap up. This slide doesn't contain enough information. That's why we're moving to the next slide.